Okay, this video is transforming and combining random variables, and this is going to be video 4 in the first probability section. So video 4. Okay, so we have some basic rules. Know that measures of center change by the constants when you add or subtract a constant. So measures of center change when you add or subtract. Know that you do not add constants to measures of spread. All right, so it works for measures of center, but not measures of spread. Know that measures of center change by the multiple when you multiply. Know that range IQR and standard deviation change by the multiple. So multiplying changes center and spread, except for variance. And variance changes by when multiplied by the square, changes by the square. So this is for variance, right? And then z-scores, which are also known as standardized scores, do not change regardless whether content is being added or the values are being multiplied. So if they ask about the standardized score, it doesn't change, and the z-score doesn't change because those are the same thing, all right? And people get confused. They don't recognize that z-score and standardized score mean the same thing. So scenario 1, a sample of 10 individuals yielded the following scaled scores. The scores were later transformed using the following rule. Okay, calculate the following. So we're going to do this. We're just going to go to stat edit real quickly, and I haven't gotten this in here. I should have, but I didn't. And we're going to enter 1, enter 2, enter 3, enter 4, enter 5, enter 6, enter 7, enter 8, enter 9, enter, and 10, enter. All right, so we've entered the data, and we're going to go stat calc one variable statistics. We don't have a frequency, so we're going to clear out our frequency. And I ended up getting an X bar of 5.5. All right, but what they're really asking for, here's my initial mean. My X bar is 5.5. But my transform score, what is that going to be? Well, that's going to be 35 times the 5.5 plus 62. Now notice I'm multiplying by the constant and I'm adding the constant because I'm allowed to do that to measure the center. So 35 times 5.5 plus the 62. And once again, and so in this case, I ended up getting a transform score of 254.5. So this is my transformed mean. And like I said, I can multiply by a constant and I can add a constant. Because it's a measure of center. This is a center. Well, the median is also a center, so I should be able to plug into the formula and do the same thing. So let's go stat calc one variable statistics, and real quickly we're going to scroll down. We'll see that we have a median of 5.5. Now it just happens the mean and median are the same because it's symmetric. It doesn't have to be, but it is this time. So in this case, this is my transformed median. Transform mean, transform median. Now they're asking for the range. So first off, the range is always going to be the largest minus the smallest. So large minus small, which is 10 minus 1. So my range is 9. So I'm going to plug into my transform formula, 35 times my raw score of 9 plus 62. But this is a measure of spread. And with measures of spread, I can't add constants. So this is just going to be, my answer is going to be 35 times 9, and that'll be it. I don't add the 62 to it. We can't add or subtract. So this answer, the transformed range, is 44. Standard deviation. So I'm going to go back into this real quickly, stat calc, and get my standard deviation. And I'm going to say this is standard deviation of the population. So it's 2.872. So this is what we have, 2.872. And this is also a measure of spread. So I'm going to plug in and I'm going to go 35 times 2.872 plus 62. But remember, we can't add constants to measure the spread. So I can only multiply. So 35 times 2.872 gives me 100.52. and that's my transform standard deviation. All right, my IQR is Q3 minus Q1. And we can go in real quickly and get that stat calc. And we end up getting a Q1 of 3, and we have a Q3 of 8. So 8 minus 3, my IQR is 5. And so this is also a measure of spread. And please remember, with measures of spread, I cannot, well, I'm going to write my formula, 35 times 5 plus the 62. But with measures of spread, we cannot add the constant. So it's going to just be 35 times 5 is 175. And then lastly, we have variance. All right, so variance is standard deviation squared. So basically, so our variance is going to be 2.872 squared. All right. Now this is also a measure of spread, but this one's different. So we have the formula 35, and I'm going to put the variance in there, 2.872. I'm going to try that again. 35 times 2.872 squared plus the 62. Well, not surprisingly, because it's a measure of spread, we can't add it. Because variance is squared, we also have to square the constant. So this is going to be 35 squared times this value squared. So 35 squared times 2.872 squared. And we end up with a very large variance of 10,104.27, 10,104.27. Now, real quickly, we can actually check some of this out. No, we'll call that good. Please memorize your rules this way. Know that if it's variance, you need to square the constant. All right. Okay, so the next one, number 7. Research indicates that the standard deviation of the human body is 0.5. So this is 0.5 with a mean of 37. Use the equation converting Celsius to Fahrenheit is F equals 9/5 C plus 32 to calculate the mean and standard deviation in degrees Fahrenheit. So they're asking us for both the mean and the standard deviation. So we'll start with the mean first. Well, I'm going to plug in 32. So F equals 9/5 times 32. Oh, excuse me, 37. I'm sorry, that should not be a 32. That should be a 37. Start over. F equals 9/5. Here's the mean, 37 plus 32. So let's do that. 9 divided by 5 times 37 plus 32. And we end up getting 98.6. It's like, oh yeah, that is actually what normal temperature is. So there's my mean. Now let's do the standard deviation for the same thing. So we have F equals 9/5. And they say the standard deviation is 0.5 plus 32. Well, remember, I can multiply by a constant, but I can multiply by the constant, but I can't add it. So that part goes away. This is because this was center, I could add it. But here, this is spread, so I can't. So it's just going to be 9/5 times 0.5. So 9 divided by 5 times 0.5. So the standard deviation for variant for degrees Fahrenheit is going to be 0.9. Okay. All right. So that's that page, which is transforming. And then we're going to move on to combining random variables. When we combine random variables, we have certain rules that apply. First off, measures of center can be added and subtracted directly. Variances can only be added, they cannot be subtracted, and they must be independent in order to do so. Must be independent. And notice we said variances. I didn't say standard deviations. Here we're going to address standard deviations. Standard deviations must be converted to variance, then the variance rules can be followed. In other words, then I can add them, but they cannot be subtracted, and they must be independent to do so. So here we go. In a certain computer card game, the player is awarded 15 points for each card that is moved to a correct place. So you get 15 points for moving to the correct place. The player is penalized 20 points for each minute the game is played. So you lose 20 for every minute. Let random variable X represent the number of cards moved to the right place. So these move to the correct spot. This is X. And let random variable Y represent the minutes. So we have 15 for every correct minus 20 minutes, or 15X minus 20Y, should you prefer. So what is the expected value in the standard deviation? Well, expected value, I can go ahead and add or subtract. It wouldn't matter, but here they're saying subtract. So the expected value is going to just be simply this, equals 15. Well, we expect it to take 9.5, so we're going to get 15 times 9.5, but we're going to lose 20 times, we expect it to take 5.4 minutes. We expect to move 9.5 cards to the correct spot. We expect it to take 5.4 minutes. And I can do this one just directly. So basically I'm going 15 times 9.5, and I get 142.5. And here I have 20 times 5.4, that's 108. And remember, I can subtract transform means. So 142.5 minus 108. And yes, you could have done this in a single step. So my expected value in this case is 34.5. That's my expected value. But then now they're also asking me for the standard deviation. Well, my standard deviation is going to be 15 times, well, 12.9 minus 20, and so this is a standard deviation, 20 times 1.1. Only I have a problem here, all right? So first off, let's calculate these. So 15 times 12.9, so this is 193.5. And this is 20 times 1.1. So this is 22. So those are this is my standard deviation because I can multiply by a constant, but I can't subtract these things. I have to square them and then add them. So I converted it to a variance, and then I take the square root of it. So I'm going to go 193.5 squared plus 22 squared. And I get that value, and then I'm going to take the square root of that. So I'm raising it to the half power, and I get 194.746. So the standard deviation of the combined and transformed is 194.746. Once again, I multiplied them because I can multiply by a constant. So that gave me my standard deviation of C. This gave me my standard deviation for M for 20 games. But then I had to square them and multiply them. All right. So the number of hybrid cars a dealer sells weekly has the following probability distribution. Okay. The dealer purchases the cars for 22,000 and sells them for 24,500. So real quickly, 24,500 minus 22,000 equals $2,500 worth of profit. All right. And but there's also a fixed cost of $500, which is going to take away some money. So the profit in dollars for a particular week can be described by the function 2,500x minus 500. So $2,500 per car, but you're going to lose a total of $500 for the week. So it says, what is the mean of Y? Problem is, I don't even know how many cars I expect to sell. So I need to figure out what my expected value. Well, my expected value is going to be 0 times 0.07 plus 1 times 0.28. And I'm just going to speed this along, plus plus 5 times 0.11. You're like, well, that's great that you sped it along. How do we go about doing that? As a reminder, you can just go to stat edit. And 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. And this is going to be 0.07, 0.28, 0.23, 0.18, 0.13, 0.11. Stat, calc, one variable statistics. Frequency list is L2, so second 2. And so I expect to sell 2.35 cars. So if I sell 2.35 cars a week, how much money do I expect to make? Well, Y equals 2,500 times 2.35 minus the 500. 2,500 times 2.35 minus 500. So I expect to make $5,375 a week. All right. So what is the standard deviation? Well, I need to know the standard deviation of this, so I need to show my work. And my work is going to be, well, the standard deviation, the square root, and in this case, it's going to be 0 minus 2.35, because I expect to sell 2 cars, times 0.07 plus 1 minus 2.35 squared times 0.28 plus plus the last one, 5 minus 2.35 squared times 0.11. So now I've shown how I'm doing this. And by the way, if this is a multiple choice question, I'm not showing all that work. But for a FRQ, I'm going to need to do that. So stat calc, and we're going to go back. We already have the information in there, and we get a standard deviation of 1.458. So our standard deviation equals 1.458, but I need to plug into that formula. So Y equals 2,500 times 1.458 minus the 500. Only we can't add or subtract constants, so this goes away. So we have 2,500 times 1.458. So we're expecting it to be 3,645. That's my standard deviation for Y. This is my mean of Y. Then it asks for the variance. Well, variance is very easy, because at this point it's like, hey, I have this, so why don't I just take this and square it? So variance is just going to be 3,645 squared. One, 3, 2, 8, 6, 0, 2, 5. Pretty big variance, all right? Okay, well, thank you for that.